Hi, welcome to learn the algorithm with me together. Today let's take a look at 215k's largest elements in an array. And what is this problem talking about? We'll be given integer array numbers and an integer k, then return the k's largest elements in the array. And first we need to know that the k's largest element is in the sorted order, not the k's distinct element. And let's take a look at the example first. And we have the array like this. We have 3, 2, 1, 5, 6, 4, and we need to find the k second is the second largest element in the array. What does that mean? And probably you're thinking in brute force is first we need to sort this array, right? If we sort this array according to in a descending numbers, so it will turns out to be 6, 5, 4, 3, 2, 1, right? So then the second one is, this is the first one and this is the second one, so the result will be 5, then we return 5. And another example is this one is, for example, we have 3, 2, 3, 1, 2, 4, 5, 5, 6. And then we need to find the fourth largest element. And of course, first we sort it. When we sort it, it will be 6, 5, 5, 4, 3, 3, 2, 2, 1, something like that. And after we sort it, now which is the fourth largest element, we are saying that is the 1, 2, 3, 4. So the result will be 4. And what is this problem saying that no, that this is the kth largest element in sorted order, not the k distinct, which means even we have some duplicate, for example, if it is the fourth distinct number, that should be 6, 5, 4, 3. So the fourth largest will be 3. But now this is not the problem we need to solve, so don't worry about that. We just find the order for this one. And now the brute force way is first we sort it, right? And next, after we sort it, we can just use an index to point it to using the k index, k-1 index to point it to find the kth largest elements, right? So this is how we do the brute force. First sort, and then we can use the k-1 index to get the number. And what is the time complexity for this one? It could be because of the sorting, so it will be on log n. And using index to get it, just constant time, so we don't have to worry about that. And how about the space? Because we don't have to use another extra data structure, just sorting on the current array, so the space complexity will be constant. That's good. And now I'm thinking any improvements on the time, right? And when we are talking about the kth largest elements or something like that, we can sometimes think of using the data structure heap to help us. Why heap can help us? Because like we can say we can use a heap. For example, this is a heap. Heap is just another priority queue. And what is the heap? Heap is a data structure can help us to maintain the order of something, right? We can maintain it like in a, or probably we can say maintain things in a descending order or ascending order. For example, like when we are going through this array numbers, like we are still using the example like 3, 2, 3, 1, 2, 4, 5, 5, 6. And then like if we are going through this number, first we put a 3 into it, right? And after we are putting 3 and then move to another one is 2. So if it is a maximum heap, it will continue to keep this order. But if it is a min heap, the 2 will go to the starting position of this queue. So a heap and the minimum heap or the maximum heap is a heap. Like for the minimum heap, it will always keep the smallest number at the end of this queue. So when we need to pull out some nodes from the min heap, it always pull out the smallest numbers from this heap. And if you're a maximum heap, it always pull out the maximum number from this heap, something like that. So continue if we are putting 3 into it, and then 3 is larger than any numbers there, so we continue at the end of this heap. And now, as I said, we need to find the kth largest numbers. So what kind of heap? Elements, right? So what kind of heap we need? Right? It's a maximum heap or the min heap. Now, because we only need the largest number, we care about the largest. So we are maintaining a min heap here. Why? Because always the smallest numbers will be at the beginning of this array. And then if it is, for example, like we only care about the k largest elements. So once the size of the heap is greater than k, what can we do? For example, like we add one more, like 1 into here, but 1 is smaller than any nodes here, so 1 will be added to the head, and then we add 2 again, so the 2 will be here. And now, because the k is 4, right? So it means that now we at least have like 5 numbers. But do we care about 1? No, we don't care about it anymore because it never be the kth largest elements in among them. So we don't care about this number. So we just move it out and we move it the smallest numbers into it. Move the smallest numbers out of this heap. So we just pull out the nodes the integer out of the heap, right? So every time we only have like the k largest elements inside it. And then when we are adding fours here, and now it also exceed the maximum numbers we can have. Now we also pull out the minimum list. So after we going through whole of this, it will be like 5, 5, 6. At this time, we also deleted like all the unnecessary nodes here. And we only have that the case nodes here. And now the smallest number here is just what we want for the case largest elements, right? The case largest element, just the smallest numbers we have, because we also don't care about the first largest or second largest, we only care about the fourth largest. So that's the reason why we can use a heap to help us. A heap can maintain first the order of the integers, and secondly, every time we are just can get the smallest numbers from the heap, and if we are maintain like a size of the case, and the smallest numbers in the in this heap is also the largest numbers, the case largest numbers, smallest numbers, smallest elements is also equals to the case largest elements, right? So this is the idea why we are using a heap here. And as I said, if the size is larger than 8, we just pull it out, right? And every time when we are looping at the array, then we put the number into heap. And then we check if the size of the heap is larger than what we expected, and then we just pull it out. And after looping the whole array, and then we just return like the smallest numbers in the heap, the smallest number of the heap, because the smallest number is just the largest element we want. And that's why we maintain the size of case. The size of the k make it the smallest number is equals to k largest number. So this is how I'm using a heap to solve this problem. And now we are talking like what is the time complexity. So the time complexity for a heap is not for a heap, I mean using the heap is first we need to go through the whole array, and when we are go through the whole array it's O(n) because we are traverse all the nodes in the array. But when we are using a heap, we also need to manage the order. And how we manage order is because we only have like the case elements into it. No, I mean no more than case elements. And a heap is the data structure of the heap is implemented in a tree. So every time when we are like popping up the nodes from left to, I mean from the bottom to the root nodes, the worst case is the height of the tree. So it will be log also the height of the tree. It depends like how many nodes. It depends on the k we have. And this is the time complexity because first we need to go through all the nodes is the on, and then we are popping up using the heap. And how about the space? I mean, popping up is log n is no more than on, so we just can remember we can ignore that. And how about a space? Because we are using a heap, we every time there are no more than k nodes, so the word case is the OK. K means the how many largest number elements into it. So this is how I use the heap. And now moving the coding part. First of all, as I said, we are using a priority queue, and we put the integer into it. New priority queue, and then we start looping all the numbers in the numbers array. And first we just put the number into the queue, and then check whether the queue size is greater than what we are expected to maintain, like the size of k. And if it is, we just pull out nodes, and after go through all of this, we just return the smallest number of the queue. And we can also say it's a peak, or you can just pull it out, but we can just return the peak of it. So that's how I solve this problem in any edge cases. And I'm thinking that, so if the numbers, there's no nodes there, let me check. Yeah, we at least have like one numbers into it, so no worry about that. And I believe that is, and let's run it. Cool. All right, so also, there's a current case. It's like if the numbers, like we only have 3 numbers, but we find the 5th largest elements in this array, that's impossible, right? And we also need to check if the k is greater than the numbers of the quantity of the numbers in the array. We also means that there's impossible, just return 1. And let's check this case, right? You can probably like say here, let's run it. All right, so expected case have value from 1 to 3 only. All right, so we don't have to worry about that. Let's just run, or we can just continue to have this and then submit it. Great, so we pass all the test cases. And this is how I solve this problem. If you are not familiar with the heap, and of course you can sort the array first and then just use an index to get the numbers. But if you know how to use a heap to maintain the order of something like the numbers or tree nodes or other things, and the heap will always help us to find the kth largest elements in something, or kth smallest elements in something. And I would say this is like the top k problem. And when we are working on top k problem, we always think about using heap. And I believe that's it. So if you think this video helped you, please give me a thumbs up. That would be great encouragement for me. And thanks for watching. See you at next video.